In this lesson, we're going to solve oblique triangles. Oblique, non-right. Given a triangle that's not a right triangle, how do we find all missing sides and angles? That's what solve means, find missing sides and angles. Well, if we're using a right triangle, if we have a right triangle that we're working off of, you might remember that we used the trig ratios of SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent hypotenuse, tangent is opposite over adjacent. So when we had a right triangle, we could use those trigonometric ratios. Okay, well, what happens when we don't have a right triangle? Then we use the law of sines. So over here, if you look at the law of sines, think of it as a formula. We have two versions. The lowercase letters stand for missing sides of a triangle, non-right. Uppercase letters represent the angles. Notice that we have three fractions that are set equal to each other. So we have ratios, if you want to think about that. Now, the only difference from over here to over here is that we've reciprocated each of the individual fractions. We've put the lowercase letters in the denominator and the uppercase letters in the numerator with the sign functions. It's just a personal preference, what version you want to use. They're both right, doesn't matter. So these equations right here with these fractions, okay, are going to help us solve oblique triangles. All right, different situations can present themselves. So if we're given two angles and one side of a unique triangle is formed. However, if two sides and one opposite angle are given, then three possible outcomes can occur. All right, we're going to look at each of these cases as we go through. Okay, so if we're given two sides and one angle, opposite angle, then three situations can evolve. It could be with the information they give you, the two sides and the one opposite angle, that there could be that there's just one triangle that results. We would only know that after verifying that a second triangle does not exist. Well, what if you're given two sides of this oblique triangle and one opposite angle? It could be that there's two triangles that result, and that's as a result of checking for a second triangle. How do you do that? That's what we're going to learn in this video. Another situation, if you're given two sides and one opposite angle, it could be that you have no triangles, that's bad information, that what they gave you won't create a triangle. How do we know that? Well, we're going to see that an inverse sign does not exist. We'll get an error on our calculator. Ready? So let's look at the single solution case. What does that mean? That's what's presented up here. Given two angles and one side, a unique oblique triangle is formed. So are they giving me two angles and a side or two sides and an angle? Well, they're giving me two angles because the uppercase letters and one side that's across from this angle. So I'm only going to have one triangle that's formed. All right, so given this information, I suggest the first thing we do is come over here to the far right and let's list what we're finding. I'm going to start with the angles first. I'm given angle C and angle B. So over here, I'm going to need angle A. I'm going to leave a blank. We'll round to 3 decimals. Okay, what are the missing sides? Well, the lowercase letters missing are lowercase a, side A, and it looks like side C. Just kind of keeps us focused. All right, so what we're going to do is maybe find the angle first. Since you're given two angles in a triangle, let's add these two values together and then subtract from 180 degrees. Because we know there's 3 angles in a triangle, so sum these two and subtract from 180. And we get 49 degrees. All right, we need to find side A and side C. I'll probably find side C first. And the reason I'm going to do that is just because they gave me a complete fraction. Notice they gave me uppercase B and lowercase b, and they gave me uppercase B. So when I come back up here, what I'm going to be doing is I'm going to be using these two fractions right here to help me find side C. So let's put a little note to ourselves. We're finding lowercase c, side C. So to find side C, if I'm going to be using this formula right here, I'm going to create a complete fraction. So I'm going to put sine of angle B, 28.7 degrees, over side B, 27.4. That is supposed to be equal to sine of C, it's given, over side C. And that's a lowercase c. Well, at this point, let's just cross multiply. So when I multiply here, I'd probably put the c up front. C times sine of 28.7 degrees equals, and then I'm going to put 27.4 up front, sine of 102.3 degrees. And then finally, solving for c, I just divide both sides by the sine of 28.7 degrees. These will divide out. So let's go to your calculator. And just insert everything into the calculator, and I got 55.747. And do I have units? Yes, I do. So this is feet. All right, what's left to find? Side A. So let's find A, lowercase a. Well, I'm going to go back to the given information and notice that I don't have an uppercase a or a lowercase a, but I do have the uppercase a here. So I'm going to need the fraction up here that has uppercase a in it. So now of these three fractions, which ones am I going to choose to set equal to each other? Well, I'll probably just choose this fraction right here. So sine of 49 degrees over my unknown a equals, and because the b information was given, I'll just return to using that fraction. Cross multiply. Divide both sides to isolate a. Don't forget to be in degree mode. So just performing this work on your calculator, use your fraction template, make sure you're in degree mode, watch out for parentheses, etc. Just be careful. 43.061, and we have a unit of feet. And I'm just going to do a real quick check. Of the three angles, A, B, and C, C is the biggest angle, so side C should have the largest value. And side C is 55, and A and B are both smaller than 55. So I feel like I did everything good. All right, this is a single solution case because you were given two angles in one side. All right, let's look at the ambiguous case. And that's what we're referring to up here. If you're given two sides and only one angle, and you've got to find two missing angles, it's possible that you're only going to get one triangle, two triangles, or it's possible that we have bad information and we have zero triangles. Okay. All right, studying what we have two sides, A and B, and then we have the angle across from angle B, 42. So over here, I'm going to list things that are missing. I'm going to need to find angle A, angle C. Of course, once I get angle A and I have B, I can easily find C. And then I need side C. So what should we find first? Well, based on the given information, I have a complete fraction with the B's. So it looks like I'm going to have to find angle A first because I'm going to be using these two fractions right here. And I've got a complete fraction and then a part of a fraction here, so that's going to allow me to find angle A. Remember, these aren't right triangles, so that's where we're having to do all this work. We can't use Pythagorean theorem or anything like that. Okay, I want to find angle A, so I'm going to do sine of A over 12. And sine of 42 degrees over 22. I'm going to go ahead and cross multiply. I'm going to divide out the 22 first. Now I'm going to go to my calculator and find this value. And what we end up with is 0.03, no. We end up with 0.3649803. I'm listing more than 3 decimals, and that's fine. Okay, now let's go to our calculator and let's do an arc sign on both sides of this equation. So when you do an arc sign here, that undoes this sign, and when you do an arc sign here, you're going to get a value that's the degrees of A, 21.406 degrees. Oop, I am so sorry. Let me push that up. Okay, so we're going to go ahead and come over here and record 21.406 degrees. All right, before I finish this though, this is where we have to check for a second triangle. So far we know we have at least one triangle, but are there 2 triangles? And here's how we check. When you get down to finding this first unknown angle, we need to stop and check its supplement, meaning this. Let me kind of come up here. I want you to think about sine of angle A is a little more than 1/3. So I'm going to go to kind of like our unit circle as perspective. You might remember that right here at pi over 6 or 30 degrees, that y-coordinate is a half, 0.5 if you will. So if I had 0.36, which is less than 0.5, that angle would probably be about right here, a little smaller than 30 degrees, which makes sense because I got 21 degrees. But where else on this circle do I have the same y-coordinate of 0.36 something? Well, we can also have a y-coordinate of 0.36 something over here, a little less than 180. So what is that angle measure over here that also has this same y-coordinate? Well, what we're going to do is we're going to say there's possibly a second angle A subscript 2, and it's equal to 180 minus, and we're going to go back and call this A subscript 1 for the time being. If I subtracted that first angle I had from 180, the value is going to be 158.594 degrees. So which answer is it for angle A? Is it this acute angle that the calculator gave me? Or should angle A over here be this angle that's obtuse that the calculator did not give me? The calculator is always going to return an acute angle for inverse sine. So, but we have to check this angle. What if the calculator was programmed? This is the way the calculator is programmed. What if the calculator is programmed to give you an obtuse angle instead of this acute angle? Because both these are correct. Well, the way we check to see if we have a second triangle is we look at the supplement, A subscript 2, and I go back and I say, okay, well, if A is 158 degrees and B is already given to being given to be 42 degrees, what happens when you add these 2 angles together? Do we have what we call second triangle? Well, no. No second triangle, because 42 degrees, the given angle that's B, plus A subscript 2 is already greater than 180 degrees. And remember, 3 angles in a triangle have to sum to 180 degrees, and if 2 of them are already more than 180 degrees, there's no room left for a third angle. So the takeaway is, when you find an angle, when there's 2 angles missing, when you find an angle for arc sine, find its supplement, go back and check that other angle that you found with the original given information. If we have more than 180 degrees, we only have 1 triangle. So that tells us we can continue and continue solving this oblique triangle. All right, so this is not, I'm just going to kind of lightly cross it off. That's not even an option. So now let's find angle C. How do we find angle C? Well, we now know A is definitely this value. Add it to B. So A plus B subtracted from 180. The sum of 42 degrees plus 21.406. Now, I haven't shown this before. It was just kind of intuitive, but this gets kind of a little weird, so that's why I thought I'd show it. So what's left to find is lowercase c, side c. All right, so to find side c, I'm going to go back to the given and notice that my complete fraction is with the b's. So to find side c, I'm going to have to involve angle c. So I'm going to set up sine of b over side b equals sine of angle c over side c. I'm going to do cross multiply. Divide both sides by sine of 42 degrees. Divide out. And I got 29.400. And go ahead and leave those zeros there because it shows that you rounded to 3 places. And remember, the unit is inches. Okay, I know it's a little foggy, maybe right here in what we did to check for a second triangle. But we're going to have more problems to practice. Okay. All right, example 2. We'll be using the law of sines because I have a complete fraction with c. I see I have side b, so I'll probably find angle b first. And it's possible that I could have 0, 1, or 2 triangles because I'm given 2 sides and 1 angle. So let's come over here and list what we're finding. We're finding angle A, angle B. It looks like side A. First thing I have to find is I have to find angle B. So I'll write that down. I have to find angle B. So use the fraction with c. So sine of 85 degrees over 15 equals the sine of angle B that I don't know over side B, which is 25. And let's cross multiply. So I'll probably do this cross first. Let's divide out 15. I'm going to have to do an arc sign in a minute, but what's this value right here? Let me see. Let me go to the calculator and find it. Okay, this value on the calculator gives us 1.66032. So now do inverse sine, arc sine of that value, and what's going to happen is you're going to get does not exist. You're going to get an error. Think about it for just a minute. If you were to go to a unit circle, where on the unit circle is the y-coordinate more than 1? Well, it's not. So whoever gave us this information gave us bad information, which is a blessing because you don't have to do any more work. So I wanted you to see what it looks like to get no solution, no triangle. When you go to do an arc sign, this value is going to be bigger than 1. You can bail out of the problem, nothing more for you to do. Let's go to the next example. Okay, notice that we're given 2 sides and 1 angle, so it's possible I'll have none or no triangle, 1 triangle, or 2. So let's list what we're finding. Angle B, angle C, side C. All right, based on the given information, I'm going to have to find angle B first because I have a complete fraction with the A's. So let's find B. Let's cross multiply. Divide that 12 out. Okay, I got 0.90470. I like to do more than 3 decimals here. All right, let's think about this before we do an arc sine. Let's go to the unit circle. Where on the unit circle would a y-coordinate be near 1? Probably, since this y-coordinate is 1, probably right there. Probably close to 90 degrees. So let's find B by doing an arc sine. Well, it's not as high as I thought. I thought it'd be closer to 90. But I ended up with 64.783 degrees. You can certainly come over here and record this, but before I do, and it will work over here, but I want to check to see if the supplement of this angle is also going to work with this problem. So as a visual, what other angle has the same y-coordinate of 0.9? Well, if I've got a 0.9 right here and a 0.9 right here, this obtuse angle, a little bit greater than 90, okay, would be also where a y-coordinate is 0.9. So how do we find this angle? Well, I'm going to go all the way over to 180 and then go back and subtract to get its supplement. So I'm going to go right here put b sub 1. So what's my other angle that the calculator could have given me, but it doesn't because it only is programmed to give acute angles less than 90. So to find b subscript 2, let's take 180 and subtract b sub 1. So b sub 2, when you subtract, is 115.217 degrees. Well, what if the calculator gave you this angle? Would it work with the original given information? Meaning if you added A and B sub 2, would you still have a value that's less than 180 to save room for angle C? Yeah, we do. So let's go back and kind of show that. We'll show that it's less than that. So I'm going to show that angle A plus B sub 2, if I added those together, I'm not sure what it equals, but I know it's less than 180 degrees. So I'm actually going to have 2 different triangles. One triangle's angle B value will be this, and another triangle's value is going to be 115. So what we're going to do is come over here and create 2 sets of answers. So I'm going to do this. And then I'm going to come down here and do B sub 2 for the second triangle. That's lowercase. So, oh joy, we have double the work. Let's see if I have enough space for all this. Okay, let's focus on this triangle first and complete it. Okay, so what I'm going to do to get B sub 1 is I'm going to come back over here and record 64.783 degrees. How do I get angle C? Well, add angle A with B sub 1. When you add those 2 together and you subtract from 180, you're going to get 94.717 degrees. So again, find C sub 1. You're going to add A plus B sub 1 and subtract from 180. So 180 minus A plus B sub 1 is equal to that angle. So now how do we find the side that's across from side C that's across from this angle measure? Well, let's find C sub 1. So I'm going to go back to the given, set up my fraction with the A's in it. Okay, find the sine of 94.717 degrees divided by C sub 1. Let's cross multiply. Okay, now we're finding a side length, so let's divide by sine of 20.5 degrees. And to save room for the other triangle that I've got to complete, let's just go to the calculator and find this value. It's 34.149 inches. Well, remember, we're not done. What if the calculator had returned when you did an arc sine this angle measure instead? It would still work. So now we're going to create a whole different set of answers for a second triangle, unrelated to these answers. All right, so what's B sub 2? Well, it's 115.217 degrees. How do we get angle C subscript 2 in a second triangle? Okay, so that's what we're going to find next, C sub 2. Take 180 degrees and subtract the sum of angle A, 20.5 degrees, plus B sub 2. And that's going to go there. And I got 44.283 degrees. And lastly, let's find side C sub 2, which is across from this angle. So I'm still going to use the same given A fraction. But now instead of using C1, I'm using C2 and finding C2. So we're going to cross multiply. I'm going to come over here. C sub 2, I'm going to get right to what it is when I divide that out. So notice it's the same fraction as up here, it's just that I'm finding the sine of C sub 2. And doing all that work, we get 23.924 inches. All right, how do we know we had two triangles? Because the supplement of the first angle I found, the supplement when added back to the original was a value that was still less than 180 degrees. So let's do one more example of that kind. Example 4, I'm given sides B and C with angle B. So the first thing I'm going to find is angle C. So I'm going to come over here and list what I'm finding. I'm finding angle A, angle C, and side A. Let me leave a little bit of room because I might have a second triangle, but I won't know until I check the supplement over here. So let's find angle C. Sine of 58 degrees over 4.5 equals sine of angle C over 5. Let's cross multiply. Divide 4.5. All right, sine of angle C is equal to 0.94228. Do an arc sine, second sine on your calculator, and I got 70.437 degrees. So for sure, I know I've got 70.437 degrees. I just don't know if I should put subscripts of 1 and then create additional spaces with subscripts of 2. All right, how do I know that there's a second triangle? Find the supplement. So let's call this C sub 1. Let's see if there's a C2. Well, C2 is 180 minus C1, which that's 109.563 degrees. So what if the calculator returned this? Because both these are correct for this equation right here. We'll check, what's 109 or almost 110 plus 58? Well, that's still less than 180. So I'm going to say yes, there is a second triangle. And that's because B plus C sub 2 is still less than 180 degrees. So I'm going to come over here and create a different set of blanks. This is going to be for the first triangle, and then I'm going to have A2, C2, and lowercase a2. So if you want to, you can go ahead and fill in C2 over here, and then we'll come back and finish that triangle a little bit later. Okay, so let me come back to the first triangle when I have this value. Go ahead and add C sub 1 to the given B to find the missing angle. So let's find A sub 1. Save some room here. What's 180 degrees minus the sum of B plus C sub 1? I got 51.563 degrees. And then what's left is side C. Oh, pardon me, side A. So find A. I'm going back to the given, and I'm going to use the fraction with b's in it. And then I'm finding what A? A goes here, so I'm finding A1, sine of 51.563 degrees. So A1. Cross multiply. And I'm just going to clean it up. When I cross multiply here, I'm going to get 4.5 sine of 51.563 degrees. But then I'm going to end up dividing it by sine of 58 degrees. And it looks like I don't have that, so I'm going to have to find that value as quick as I can. So A sub 1 is 4.156. I don't know if there were units. Yeah, there were feet. Okay. All right. Is A the smallest angle? Yes, it is. So the A sub 1 should be the smallest side. Okay, now let's focus on the second triangle. What if, now forget everything you've done, but come over here and now let's use C sub 2, which we got. How do we find A then? Well, we go back and add 109.563 to 58 and subtract from 180. That's a small angle. I got 12.437 degrees. So again, find A sub 2. It's 180 degrees minus the sum of the given B plus C sub 2. And that's what gave us that. And finally, let's find A sub 2. And do your cross multiplication. And then I don't have that value either, but I'll try and find it pretty quickly because I know it's 4.5. I want to build a fraction. Oh yeah, that should be small. That's a small angle. 1.143 feet. All right. Okay. I know that was a little long, but those ambiguous cases where you have two triangles are a little bit long too.